Hello everyone, welcome to the course on chemistry. In previous video, we have seen the crystal defects. What are the types of crystal defects and what is the meaning of crystal defects? And there are two types of crystal defects. One is point defect and another one is line defects. So we have started the study of point defects, where we have seen that the point defects are classified into three types. Those are stoichiometric defects, non-stoichiometric defects and impurity defects. And we have studied the stoichiometric defects, where they are classified further into two types. Those are vacancy defects and interstitial defects. And again, in ionic compounds, we have seen two types of crystal defects. Those are Schottky defect and Frenkel defect. So one of the important concept in solid state, that are Schottky defect and Frenkel defects. Now we will study about the second type of crystal defect, that is non-stoichiometric defects. So what does this non-stoichiometric defects means? As you already know that the stoichiometric defects, they will not alter the stoichiometry of the crystal, and hence they are said to be stoichiometric defects. But non-stoichiometric defects means these will alter the stoichiometric of the compound. So whenever a defect arises in a compound, then it will alters the stoichiometry of that compound, and hence these compounds or these defects are said to be non-stoichiometric defects. And such compounds whose stoichiometry is altered are said to be non-stoichiometric compounds. So what are the different types of non-stoichiometric defects that we study? So here the non-stoichiometric defects are classified into two types. One is metal excess defect. Metal excess defect. And another type of non-stoichiometric defect is metal deficiency defect. Metal deficiency defect. So these are the two types of defects that we observe in non-stoichiometric defects. So this metal excess defect, it is again arises due to two reasons. So what is the cause for the metal excess defect? Why this defect will arise? So this can be explained due to two reasons, and one of them is due to formation of anionic vacancy. Due to formation of anionic vacancy, and another one is due to presence of extra cation at interstitial site. Interstitial site. Okay, so there are two reasons for metal excess defect. One is due to formation of anionic vacancy, and another one is due to presence of extra cation at interstitial site. So these are the two reasons for metal excess defect. And what are the reasons for metal deficiency defect? Again, it is also arises due to two reasons. One is due to formation of cationic vacancy, and another one is due to presence of extra anion at interstitial site. So these are the two defects of non-stoichiometric defects, and what are the reasons for arise of those two defects is due to these four reasons. Okay, now we will study one by one the metal excess defect and metal deficiency defect in detail. So let us study the metal excess defect which is arised in a crystal due to the formation of anionic vacancy. So how this defect is arised in this crystal? So let us consider a crystal of NaCl. Okay, NaCl crystal where alternatively Na plus and Cl minus are arranged in the crystal. This is the NaCl, sodium chloride crystal, and I have represented the Na and Cl ions in the crystal like this. So now it is a perfect ideal crystal. When you observe this, you can say that the particles are regularly arranged and there is no irregularities or deviation in the arrangement of crystal, and hence it is an ideal crystal. Okay, it does not consist of any defect. Now I will do one thing, that I will heat this crystal in presence of sodium vapors. Okay, I will heat this NaCl crystal. I will take some of the NaCl crystal, okay, sodium chloride salt, and I will heat that sodium chloride salt in presence of sodium vapor. Okay, so upon heating this NaCl crystal in presence of sodium vapors, the Cl minus ions which are arranged inside this crystal, they will go to the surface of the crystal. Okay, so whenever I heat this crystal, the Cl minus ions, they will diffuses to the surface of the crystal and reacts with Na ions which are present in the outermost surroundings. Okay, so when we heat, the Na gets combines with Cl minus and forms NaCl crystal on the surface of this crystal lattice. So when Cl minus diffuses here, what happens? Here an vacancy is created because NaCl gets accumulated on the surface of the crystal. But now another thing you have to remember here, you should maintain the electrical neutrality. Okay, so in order to maintain electrical neutrality, what we have to do? Now simply see here, is it electrically neutral? When the crystal is electrical neutral, when there is a presence of equal number of cations and anions present in the crystal, then the crystal is said to be neutral. But now see here, how many Na plus ions are there, that is cations, and how many Cl minus ions are there, which are act as anions. So 1, 2, 3, 4, 5, 6. 6 Na plus ions are there. So those are positive charges. Then anions 1, 2, 3, 4, 5. So totally 5 Cl minus ions are there. The Cl minus which is present here, it is moved to the surface of the crystal and reacts with Na, sodium vapors. That sodium Na will gives one electron to Cl and becomes Na plus, and it accepts the electron and becomes Cl minus and forms NaCl. Now what about this? Now the crystal should maintain the electrical neutrality. In order to maintain electrical neutrality, the crystal should contain equal number of positive charges and equal number of negative charges. So here totally 6 positive charges are there, but here how many negative charges are there? 5 negative charges are there. So that can be maintained by putting one electron in this vacant site. Okay, this is vacancy. Vacancy means empty space. An ion is moved here. So here it will form vacancy, and it is created due to what? Due to Cl minus, which is an anion, and hence it is known as an ionic vacancy. Okay, the vacancy or vacant site obtained due to removal of anion will be called as anionic vacancy. And here the electrical charge is maintained by putting one electron here. So this electron comes from where? Where you get this electron? This electron is left by Cl, because the Cl initially it has gained an electron from this Na and becomes Cl minus. But now another Na will give the electron to the Cl here. So hence the Cl will take the electron from this Na and leaving back the electron in the vacant site, which is obtained from Na plus. And hence now calculate how many positive charges are there? 6 positive charges. Okay, and how many negative charges are there? It has left electron. So if it is left electron, that means it has negative charge, and hence the negative charges, number of negative charges will become 6, and hence the equal number of positive and negative charges will be formed, and it becomes electrically neutral. And if you observe this electron, whenever you supply the heat or when you pass the radiation through this crystal, the electron will move to the excited state, from ground state to excited state, and again it comes back by releasing photon. Okay, so the electron which is present at this vacant site will get excited when you pass the radiation. Upon passing the radiation, it will move to the excited state and again falls back to the ground state. While falling back to the ground state, it will emit the photon, and hence the crystals gets color. Okay, the crystals of NaCl will gives yellow color on heating. It gives yellow color on heating. It is because of presence of this electron. Because while coming back to the ground state, it will emit the photon which is yellow in color. Okay, the different crystals emit different colors. Okay, in NaCl the color will be yellow, and hence it will get yellow color. So crystals are colored on heating because of presence of this electron at vacant site, and this electron which is embedded in the anionic vacancy is said to be F center. It is known as F center. F means Farbenzenter. It is a German word that means color imparter. Okay, or color center. You can write it as color center. Farbenzenter means color center. Okay, so it gives color to the crystals, hence it is known as F center. Very important for 1 mark questions. Okay, so solid state, you can get the question what is F center. In 2 marks question only they may ask what is the cause of metal excess defect and give one consequence of metal excess defect. The cause for metal excess defect is due to formation of anionic vacancy. And what is this consequence? It gives color to the crystals. Okay, or what is the consequence of F center? It is nothing but it gives the color to the crystal. That is one of the consequence of F center. Okay, so this is about metal excess defect due to formation of anionic vacancy. You can also give the different examples like lithium chloride. When it is heated, it gives pink color. It is because the lithium chloride, it emits a pink color, and hence the color of the crystal becomes pink. There also the F center is present, and hence it is pink in color. And if you take the KCl, it is having lilac color or violet type color will be obtained. Okay, so these are some other examples for metal excess defect due to formation of anionic vacancy. So next cause for metal excess defect is due to presence of extra cation at interstitial site. So in the name only it suggests what is the reason for the metal excess defect. So again consider the crystal. Okay, any crystal, that should be ionic crystal, where the alternate positive and negative ions are present. So A plus, B minus. So alternatively I have taken the positive and negative ions. So now it is again an ideal crystal with no defect. Now how does the defect will arises here? So when we change the temperature, okay, or heat the crystal, some of the ions, okay, they gets accumulated. Okay, so some of the extra cations which are present, they will get accumulated in the interstitial site. Okay, and hence it will leads to the metal excess defect. So when we heat the ZnO, okay, the Zn plus 2 ions, okay, that is cation, they will get accumulated at the interstitial site. And when they get accumulated in the interstitial site, the defect will arises. And along with this, okay, now the irregularities observed in this crystal due to presence of this cation, and now it has to maintain the electrical neutrality. ಅದು ಏನು ಮಾಡಬೇಕು? ಎಲೆಕ್ಟ್ರಿಕಲ್ ನ್ಯೂಟ್ರಾಲಿಟಿ ಮೇಂಟೈನ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಎರಡು ಏನಿರಬೇಕು? ಈಕ್ವಲ್ ಇರಬೇಕು. ಈಗ ಇಲ್ಲಿ ಒಂದು ಕ್ಯಾಟಯಾನ್ ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ ಅಪಾನ್ ಹೀಟಿಂಗ್ ಯಾವಾಗ ಬರುತ್ತಾ? ವೆನ್ ವಿ ಹೀಟ್ ದಿ ಕಂಪೌಂಡ್, ಸಮ್ ಆಫ್ ದಿ ಅಯಾನ್ಸ್ ಗೆಟ್ಸ್ ಅಕ್ಯುಮುಲೇಟೆಡ್ ಇನ್ ದಿಸ್ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್. ಹೌದಾ? ಈ ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಒಳಗ ಇಲ್ಲಿ ಏನು ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್, ಇಟ್ ಈಸ್ ಆಲ್ ನೋನ್ ಆಸ್ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್. ಈ ಎಂಟಿ ಸ್ಪೇಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್ ಒಳಗೆ ಬಂದು ಏನಾಗುತ್ತೆ? ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಕ್ಯಾಟಯಾನ್ ಅಕ್ಯುಮುಲೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಎಕ್ಸ್ಟ್ರಾ ಕ್ಯಾಟಯಾನ್ ಬಂದು ಕುಂತಾಗ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಅದು ಇಲ್ಲಿ? 1 2 3 4 5 6 positive charges. Okay, and how many negative charges? 1 2 3 4 5 negative charges. Okay, now we need to maintain the electrical neutrality. ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಎರಡು ಏನಿರಬೇಕು? ಈಕ್ವಲ್ ಇರಬೇಕು. then the electron gets trapped in these interstitial sites. Okay, ಆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ನ್ಯೂಟ್ರಾಲಿಟಿ ಮೇಂಟೈನ್ ಮಾಡೋ ಸಂಬಂಧ ಏನಾಗತ್ರಿ ಇಲ್ಲೇ ಕ್ಯಾಟಯಾನ್ ಏನು ಬಂದು ಕುಂತಿರುತ್ತ, ಇಟ್ ಹ್ಯಾಸ್ ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಮಾಡ್ಕೊಂಡಿರುತ್ತ. ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗತ್ತ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್ ಒಳಗೆ ಬಂದು ಕುಂತ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಡ್ಯೂ ಟು ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಗೇನ್ ದಿ ನಂಬರ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಅಂಡ್ ನಂಬರ್ ಆಫ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಬಿಕಮ್ಸ್ ಈಕ್ವಲ್. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದು ಕುಂದ್ರೋದ್ರಿಂದ ಪಾಸಿಟಿವ್ ಮತ್ತು ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಎರಡು ಏನಿರ್ತಾವು ಈಕ್ವಲ್ ನಂಬರ್ಸ್ ಒಳಗಿರ್ತಾವೆ. ಓಕೆ, ಅಂಡ್ ಹೆನ್ಸ್ ದಿ ಕ್ರಿಸ್ಟಲ್ ಈಸ್ ಸೇಡ್ ಟು ಬಿ ಎಲೆಕ್ಟ್ರಿಕಲಿ ನ್ಯೂಟ್ರಲ್. ಓಕೆ, ಪಾಸಿಟಿವ್ನು ಇರೋದಿಲ್ಲ, ನೆಗೆಟಿವ್ನು ಇರೋದಿಲ್ಲ, ಏನಿರುತ್ತೆ ನ್ಯೂಟ್ರಲ್ ಆಗಿ ಉಳಿತದೆ. ಅಗೇನ್ ಡ್ಯೂ ಟು ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿಸ್, ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದ್ರಿಂದ ವೆನ್ ವಿ ಹೀಟ್ ದಿ ಕಂಪೌಂಡ್ ಅಥವಾ ಒಂದು ರೇಡಿಯೇಷನ್ ಪಾಸ್ ಮಾಡಿದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅವಾಗ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಏನು ಮಾಡುತ್ತಾ ಇಟ್ ವಿಲ್ ಎಮಿಟ್ಸ್ ದಿ ಕಲರ್. ಆಗಲೇ ಹೇಳಿದಾಗೆ ಏನಾಗುತ್ತಾ ಎಲೆಕ್ಟ್ರಾನ್ ಜಂಪ್ಸ್ ಟು ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಅಂಡ್ ಕಮ್ ಬ್ಯಾಕ್ಸ್ ಟು ground state. Okay, it is the ground state. Now while coming from excited state to ground state, excited state ದಿಂದ ground state ಗೆ ಬರಬೇಕಾದ್ರೆ ರೇಡಿಯೇಷನ್ ನ ಏನು ಮಾಡುತ್ತದು ಎಮಿಟ್ ಮಾಡುತ್ತ. ಅದಕ್ಕೆ ಏನು ಅಂತ ಹೇಳ್ತೀವಿ ಫೋಟಾನ್ ಅಂತ ಹೇಳ್ತೀವಿ. and this photon which is released is colored and hence the crystal gets colored on heating. ಯಾವಾಗಲೂ ಹೀಟ್ ಮಾಡಿದಾಗ ಮತ್ತೆ ಈ ಕ್ರಿಸ್ಟಲ್ಗೆ ಏನು ಬರುತ್ತಾ ಕಲರ್ ಬರುತ್ತಾ. ಯಾಕೆ ಕಲರ್ ಬರುತ್ತಾ? ಡ್ಯೂ ಟು ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್. ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ನೋನ್ ಆಸ್ ಎಫ್ ಸೆಂಟರ್. ಓಕೆ, ಸೊ ರಿಮೆಂಬರ್ ಒನ್ ಥಿಂಗ್, ಒಂದು ನೆನಪಿಟ್ಕೋರಿ, ಯಾವಾಗಲೂ ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಕಲರ್ ಬಂದದ ಅಂತ ಹೇಳಿದ್ರ ಎಸ್ಪೆಷಲಿ ಇನ್ ಸಾಲಿಡ್ ಸ್ಟೇಟ್, ಇಫ್ ದೇ ಆಸ್ಕ್ ಅ ಕ್ವಶನ್, ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಒಳಗೆ ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ರು, ವೈ ದಿ ಕಂಪೌಂಡ್ಸ್ ಆರ್ ಕಲರ್ಡ್ ಆನ್ ಹೀಟಿಂಗ್? ಇಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ಎಫ್ ಸೆಂಟರ್. ಯಾಕೆ ಕಂಪೌಂಡ್ಸ್ ಅಥವಾ ಕ್ರಿಸ್ಟಲ್ಸ್ ಕಲರ್ ಆಗಿರ್ತಾವು ಅಂತ ಕೇಳಿದ್ರ ಅವಾಗ ನೀವೇನು ಹೇಳಬೇಕು? ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಎಫ್ ಸೆಂಟರ್ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ, ದಟ್ ಈಸ್ ಕಲರಿಂಗ್ ಸೆಂಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ದಿ ಮೆಟಲ್ ಎಕ್ಸೆಸ್ ಡಿಫೆಕ್ಟ್ ಡ್ಯೂ ಟು ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಎಕ್ಸ್ಟ್ರಾ ಕ್ಯಾಟಯಾನ್ ಆಟ್ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್. ಇಲ್ಲೇ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಕ್ಯಾಟಯಾನ್ ಇರೋದ್ರಿಂದ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಸೈಟ್ ಒಳಗೆ ಮೆಟಲ್ ಎಕ್ಸೆಸ್ ಡಿಫೆಕ್ಟ್ ಅರೈಸ್ ಆಗುತ್ತೆ. Another question may come in mind of you. So here metal excess defect. Why we call this defect as metal excess defect? ಇದಕ್ಕೆ ನಾವು ಯಾಕೆ ಮೆಟಲ್ ಎಕ್ಸೆಸ್ ಡಿಫೆಕ್ಟ್ ಅಂತ ಹೇಳ್ತೀವಿ? ಇದು ಆಯ್ತು ಅಥವಾ ಪ್ರೀವಿಯಸ್ ಒನ್ ಡ್ಯೂ ಟು ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ anionic vacancy. So simply count the numbers here. ಕ್ಯಾಟಯಾನ್ಸ್ ಎಷ್ಟು ಅದಾವ ನೋಡ್ರಿ, 1 2 3 4 5 6 7. 7 ಏನದಾವು ಕ್ಯಾಟಯಾನ್ಸ್ ಅದಾವ. ಆನಯಾನ್ಸ್ ಎಷ್ಟು ಅದಾವು? 1 2 3 4 5 6. 6 ಕ್ಯಾಟಯಾನ್ಸ್ ಅದಾವ, 6 ಆನಯಾನ್ಸ್ ಅದಾವ. ನಾವು ಈ ಕ್ಯಾಟಯಾನ್ಸ್ ಯೂಶುವಲಿ ಯಾವ ಇರ್ತಾವ್ರಿ? ದೀಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ಮೆಟಲ್ ಅಯಾನ್ಸ್. ಅವು ಏನಾಗಿರ್ತಾವು? ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಆಗಿರ್ತಾವ. ಇಟ್ ಮೇ ಬಿ Na ಪ್ಲಸ್ ಅಂತ ತಗೋರಿ, ಅಥವಾ Mg+2, Zn+2. ಓಕೆ, ವಾಟ್ ಎವರ್ ಕ್ಯಾಟಯಾನ್ ಯು ವಿಲ್ ಟೇಕ್, ದೇ ಆರ್ ಆಲ್ ನಥಿಂಗ್ ಬಟ್ ಮೆಟಲ್ ಅಯಾನ್ಸ್. ಅಂಡ್ ದೋಸ್ ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಆರ್ ಗ್ರೇಟರ್ ಇನ್ ನಂಬರ್ ಆಸ್ ಕಂಪೇರ್ಡ್ ಟು ಆನಯಾನ್ಸ್. ಆನಯಾನ್ಸಿಗೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಕ್ಯಾಟಯಾನ್ಸ್ ನಂಬರ್ ದಟ್ ಈಸ್ ಮೆಟಲ್ ಅಯಾನ್ಸ್ ನಂಬರ್ ಏನಿರುತ್ತೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಆರ್ ಎಕ್ಸೆಸ್ ಇನ್ ದಿಸ್ ಕ್ರಿಸ್ಟಲ್. ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಏನಿರ್ತಾವ್ರಿ ಜಾಸ್ತಿ ಇರ್ತಾವ ಈ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಒಳಗೆ. ಓಕೆ, ಹಂಗಾಗಿ ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಮೆಟಲ್ ಎಕ್ಸೆಸ್ ಡಿಫೆಕ್ಟ್. ಓಕೆ, ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಅಲ್ಲೇನಂತ ಹೇಳ್ತೀವಿ? ಮೆಟಲ್ ಎಕ್ಸೆಸ್ ಡಿಫೆಕ್ಟ್. ಯಾಕೆ ಜಾಸ್ತಿ ಆಗಿರ್ತಾವು? ಯಾಕಂದ್ರೆ ಅಲ್ಲೇ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಕ್ಯಾಟಯಾನ್ ಆದ್ರೂ ಇರುತ್ತೆ ಅಥವಾ ಒಂದು ಆನಯಾನ್ ರಿಮೂವ್ ಮಾಡಿರ್ತೀರಿ, ಅವಾಗಲ್ಲೇ ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಜಾಸ್ತಿ ಆಗಿರ್ತಾವ. ಮೆಟಲ್ ಅಯಾನ್ಸ್ ಜಾಸ್ತಿ ಆಗಿರೋದ್ರಿಂದ ಅಲ್ಲಿ ಡಿಫೆಕ್ಟ್ ಅರೈಸ್ ಆಗುತ್ತೆ. ಆ ಡಿಫೆಕ್ಟ್ಗೆ ಮೆಟಲ್ ಎಕ್ಸೆಸ್ ಡಿಫೆಕ್ಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ನಂಬರ್ ಆಫ್ ಕ್ಯಾಟಯಾನ್ಸ್ increases and hence it is said to be metal excess defect, and this will arise due to formation of anionic vacancy and due to presence of extra cation at interstitial site.